Somehow it's ChatGPT and generative AI that made the streaming of events a norm. Right now we expect to see something like this in our browser, an experience that makes it as if somebody is typing back at us the response to our questions. Now, the SSE or server sent events was not the only thing that allowed us to do that. WebSockets have been with us for years. Now, if you open up your stock trading application and you want to see how the quotes are updating live, that is typically, WebSockets, and it predates SSE for a good number of years. The difference between the two are a bit subtle, like the WebSockets allow you for bidirectional stream, and SSE is typically a one-way streaming from the server to the client. That is why the WebSockets is more feature-rich, albeit being a bit more complex, as you would need to write your own kind of wire protocol. And today, we're going to talk about how we can use these streaming capabilities that HTTP now offers in something more network related. Because if you think about it, networks are actually very much needing to have this kind of streaming capability, because a lot of the events are happening in the networking. You have interfaces flapping, you have new routes being added to your fib and rib, and you want to actually react to those events. And if you are really event-driven system, then you don't just glue up webhooks together. You actually want to have something like a pops up in the core, and then one of these technologies in the streaming between the clients of your servers, and the servers needs to support streaming. Okay, so this is Roman. Today we are going to talk about the VS Code extension for Nokia EDA. And if you want to kind of close this window right away because you don't have interest in EDA, two things. You don't have an interest in EDA yet. And the second thing, we will talk about the capabilities that one can use today with modern IDEs like VS Code and the modern streaming technologies in the HTTP domain. So maybe next time you get to build an extension of your own, you can leverage one of these things and maybe even ask your provider to support streaming for the APIs. So let's get going. So what we're looking at right now is the EDA UI, our graphical interface for users to interact with the system. In particular, we're looking at the EDA query language, the query language that allows you to query your network in a distributive manner, kind of looking glass for your network with superpowers. And what I wanted to draw your attention to is this summary of in BPS and out BPS that you see on the screen. They are updating live. It's not like a lot of GET requests coming every second to get the data out. It's a WebSocket connection that is established from your browser, rendering the EDA UI towards the EDA API server. But then what happens next? The EDA API server has hooks to the PubSub infrastructure of the EDA itself. And one of the components in EDA that talks to the nodes is actually subscribing with GNMI on change to the statistics of the interfaces. And that is how we get all of these statistics from all of the nodes into the system, and then being able to stream it back to the UI client so that we can render the data live out. This is, in principle, what kind of powers this reactivity of events. This is how we are able to get the data in real time rendered back at you for your UI client. But can we do the same for a VS Code extension? That was an interesting question, and my colleague Florian, who's like an expert in VS Code extension building by now, he wrote an extension for EDA, and he used WebSockets, the same technology that our browser application uses to connect to the system and get the data out. He used the same for VS Code extension. So let's see how this works there. Okay, so this is my VS Code. I stripped it down from all of the extensions that I have so they don't get in the way with the default theme. And we want to install the EDA extension, right? We go to the extension store, we type Nokia EDA, and there it is. 5 stars, please continue this trend. We install this, it gets installed, and you see this nice Echidna icon in your extension list. If you click on this one, you will get the configure EDA targets window, which allows you to configure the API of the EDA which you want to connect to. And that is exactly what we're going to do now. Like, if you want to open this window again, you can just click on this gear icon and you will see the configure EDA targets window like I'm looking at here. Now, I need to configure my extension so that it knows where to connect to the EDA API server. And you can have many of those. Like if you have different EDA systems, like your development system, your production system, your testing system, you can add these targets here and then you will be able to switch between them. So I'm clicking on add new, and I know that my EDA that I deployed using the Try EDA experience, which is a free way to install the platform, no need to provide us any information, not even an email. You can just pull down the installer and build a system that I have built before. So it's in my VM with this address and this particular port that I used. I can also select the Kubernetes context, and it's an optional field because you don't have to, but you probably want to because we use Kubernetes for either showing you the Kubernetes resources that you might be interested in, and we also use kubectl command in the background to do some clever stuff. The good thing is that the extension will detect what Kubernetes context you have in your system, and I have this one that relates to my EDA system that I want to demonstrate. I select this one. My default namespace is EDA system. I did not change that. That is the default value. The username is default as well, but I have a custom username password. So I type it in, and I also need to retrieve the client secret, which is OAuth2 way of API clients to authenticate against the identity provider. So if I click retrieve, we'll have this little box here asking us to authenticate with Keycloak to get the client secret out. In production, you would typically get the client secret from the administrator, so you would not have to do that. But for trials and demos and your testing systems, you can just get the client secret from the Keycloak if you know the credentials. They are admin, and you may change your Keycloak password. I did that. By default, it's admin. We do this, and client secret retrieved successfully. You see it's just a gibberish string, but now I also click skip TLS verification because I did not bother to create certificates. I click save, and now I need to reload my window so that the extension kind of takes in all the new information that we provided it with. After I reload the screen, you see that a bunch of things started to get populated in this panel. First of all, we see that some alarms are there, we see transactions, we see some panels. That is amazing. That is what you will see when you install the extension and you will configure it with the address information of your EDA cluster. Well, first of all, let's figure out what we have in our Try EDA system. By default, we get to see like 2 leaf nodes and 1 spine nodes. But how do you know that? Like if you don't really know what we baked into the Try EDA experience, you can now click on this topology dashboard and it will display the actual topology that you have in your cluster. As I said, we have 2 leaves, we have 1 spine. There are 2 interswitch links between each pair of leaf spines. But it's not only this. You can click on the node, you can click on leaf 2, and first of all, it will highlight the interfaces that are connected to this particular node. We see these 2 interfaces have been highlighted. They are now in bold green. And on the right-hand side, we see a bunch of information that are critical to this node. We see the labels that are assigned to this node. We see the node details, the IP address that it has, the operating system, the platform that this node uses, its SR Linux, D3L, and the version that it runs. Fantastic. But that's not all. You can also click on the link, and the link will say what kind of link it is. It's a leaf 2 to spine 1 interswitch link. It's in the state up. It has local endpoint, which is local to leaf 2. And the interface we use is Ethernet 1.2. It is denoted here in short version E12. And the remote endpoint is Ethernet 1.4. That is the one that is connected to the spine. Great. But we can double click on the node and see what happens. We are connecting to the node. So if I type in my SR Linux password, I will be able to log in to the node. How cool is that? And this would work with hardware systems as well. Like if you EDA manages hardware nodes, you will be able to see them in the topology. You will be able to double click on them and get the shell to your nodes from the VS Code. Like, the importance of VS Code here is that for many users, VS Code is actually their most used application. Like my screen time statistics will say that VS Code is probably always running when I open the lid of my laptop. And for many users, it is the IDE they use. Now, if we can get more tooling in the VS Code through extensions, that makes it less context switching, more familiar interfaces, and just easier to use different tools together in the same kind of ecosystem of extensions. All right, so I'm in my shell of my node. So it's a real node. It's of course it's simulated. It's a tri-D experience, which means that these nodes are running as containers inside the Kubernetes cluster that EDA runs in itself. But it's the same container that you would run in ContainerLab. It's the same image that you would see in your in your hardware, right? It would be the same control plane experience that you get with the simulated topology here. Yeah, same information, version 25.7.1, SO Linux. Great. But now let's go back to the resources. Like this is the panel that you will spend quite a lot of time in. What resources show is three different components. It shows the two namespaces, EDA and EDA system. The EDA system is where you have your resources that are related to the core of the system. There are like the topologies that we configured in the system. There's these catalogs and registries. That's where we download the applications from. But the most important one is the user namespace, which by default is named EDA. This is where you configure your resources that define your infrastructure. For example, if I open up the interfaces category, this is where I see all the interface intents that we pre-created when we deployed the Tri-EDA cluster for you. So you see here that we have the lag interface between leaf 1 and leaf 2, which uses the Ethernet 1.2 on both nodes, and we see a lot of leaf interfaces, leaf 1 in Ethernet 1.1, leaf 1 Ethernet 1.2, and so on and so forth. So these interfaces are our intents that we created in the system, and these intents are honored, and they are resulted in the configuration on the nodes. So now our nodes are configured with these particular interfaces. Now this is the state of truth for your network, right? This is where you lodge your intents, and when you have them here, this is what keeps the state synchronized with the actual configuration elements on your network operating systems. Like if I would remove one of these interfaces, they will be removed from the configuration of the relevant nodes. When something changes, the state is reflected in the cluster itself. Now, for example, what I wanted to show you here is if we click on leaf 1 Ethernet 1, we will see the resource that defines the interface 1.1 on leaf 1. So you see here that it's exactly modeled after the Kubernetes resource model. It has the metadata, it has the API version and the kind. In the spec field, you see that we want this interface to be enabled. We have the Ethernet blob here. We enable LLDP for this interface, and we also denote what members should be part of this interface. And because we have a list, you kind of can guess that it can be a lag interface as well. So a single abstracted interface allows us to define an interface without really tying it up to a particular network operating system. And that is because EDA is a multi-vendor system, so you can use the same configuration intents for multiple operating systems. That is why our goal is to keep these intents as abstracted from the actual implementation as possible, and at the same time as flexible as possible to make sure that you can configure small little knobs on different operating systems. But for the interface sake, we have these top-level parameters that we kind of went through, and we also have these members that say, hey, this is leaf 1 that should have been added to the members, and on leaf 1 we should use the Ethernet 1.1. The cool thing about this VS Code extension is that it pulls up all the OpenAPI specifications from the cluster. Remember, I did not configure any, I did not downloaded any Yang files. I did not downloaded any JSON schemas, nothing. But at the same time, if I go and hover over this enabled field, it will say enable or disable the interface. If I go over the members, it will say list of members on which to apply properties. For single interface, this would be a list of 1. If I go to LACP port priority, it will explain what it is. Where do we get this information from? The VS Code extension, when it connects to the cluster, it pulls down all the Open API from the cluster because it resides with the cluster, and it knows the schema for this interface. We did not even say that this is the interface resource in EDA, but the extension is smart enough to correlate the schema that it downloaded when it connected to the node so that we have this inline documentation for all of the fields. You don't have to guess. And if I, for example, if I change this LACP port priority to foo, I need to edit the resource. Like if I change this to foo, look what happens. It is marked its incorrect type, expected integer, because the LACP priority is an integer in the OpenAPI schema. And when I put in some gibberish, I will see immediately here that I violated the contract with my API. Okay, so I don't want to do anything here just yet. So we're still browsing the interface resource. If you look here, you will see that it says state up. What is this? Like the interface that we defined with these parameters, it's not only the configuration intent, it also, like in Kubernetes, it also has a status field. It means that once we configure this, once we lodge this intent to a cluster, we also get the state of it back. Now, this is a very important piece in EDA. We don't only challenge the configuration problems in the infrastructure. We also want to have the state pulled back for the resource that we configured in the cluster. Like here, when we created an interface, you see that there is this status block here, right? This guy. And it has a bunch of state information pertaining to this particular resource. Like, hey, the state is enabled true. The last change that happened to this resource, whether this particular timestamp, the members that we have configured in the spec, they actually been detected, and the neighbors is the neighbor of this interface on the remote side. Remember that this is the leaf1 interface 1, but in the state we actually know the neighbors. These are, let's actually look, list of discovered neighbors on this member, which means discovered, LLDP discovered. So our state information will contain the state of this resource, not the configuration. Actually, the configuration is an easy part. The challenge is in the state. And we, in EDA, we kind of get the state back and we associated it back with the resource. And you will see a lot of state information with our resources. Like, yeah, we have the operational state up because we know that the operational state of the resources is up and it's coming back to us from the streaming telemetry. Speaking of the streaming telemetry, something that we did not kind of display so far is that this is all live. This is all streamed back. This all shows an immediate effect when things are changing with the nodes. How do we demonstrate this? Okay, let's go to leaf2, right? We are looking at leaf1 Ethernet 1.1. Let's open leaf2 Ethernet 1.1. So I'm opening leaf2 Ethernet 1.1 here. This is the resource. And I'm on my leaf2. So what happens if I go to candidate mode and I say interface Ethernet 1.1 admin state disable? I will commit this guy, but before I click enter, let's pay attention to this line. It's now green. It says state up. I'm clicking enter. Look at this. It is immediately drawn as down. It's not even a split second that happened between the change state on the node. Remember, this is simulated node in container, in Kubernetes cluster, but the change state happened immediately. And now if we open this up, I need to close this window, reopen it up. Look at this. The operational state is down now in the status of the resource. Like, we changed the admin state on the node. The configuration subscription with GNMI, the extension that we added to the OpenConfig GNMI, it bubbled down this change with on-change streaming telemetry to the EDA controller. Let's call it controller, just to make it simple. This event has been propagated through a set of state scripts that regurgitated the information. Eventually it was streamed back to my VS Code being an API client, and we displayed it here. Now, this happened very fast. This is really great, but it's not only this. If you were paying attention, you saw that it's not only this state that had changed. We also had more alarms populated here, and we also got the deviation. Now, the deviation is something that a lot of our competitors try to figure out how to do. When you have a real event-driven system, it's actually not that hard, because what configuration subscriptions allow us to do is it allows us to immediately detect when the intent is deviated from the actual state that we get with configuration subscriptions. Because what we actually did is that we detected that the state has changed between the intent in this resource, that is what we denoted with this spec field, and the information that we got back with configuration subscriptions. And if I click on this deviation, it actually shows me what happened. My deviation that wanted to have admin state enabled, because that was in my intent, in my leaf to Ethernet 1.1 intent, I wanted it to be enabled. The diff is actually that it is disabled. And the associated resource that got affected by this is leaf to Ethernet 1.1 kind interface. So this is what actually got impacted by this, right? So you can now see the deviations being part of your VS Code extension that are rapid as, and you can actually see that if I discard this deviation, the state goes back immediately. And even in the topology, the tuple link interface became green. It was red before because the interface was down. After I discarded the deviation, it all came back to the original intent state. How cool is that? I think it's pretty massive and fantastic. And it's all based on streaming. Okay, so this was a bit of the exploration of the resources, how we deal with them, and what can you expect here. As I said, everything you see here is declaratively defining the state of your infrastructure. The resources that are here define what you have on the system. And to demonstrate this further, I will try to create a banner resource. If I log into leaf 1, for example, there is no login banner. There's like a login prompt, but there is no welcome message whatsoever. I just see the prompt and the default kind of welcome to Nokia or Linux message. But there is no banner that I have configured, and I want to have one. So how do we do that? How do we do a simple step of configuring a new resource through EDA VS Code extension? Let's see how it's done. Here you will see the plus button. The plus button says create a resource. We click on this one and it asks us what resource do we want to configure. But what it lists here is a bunch of resources that have already been installed on the system. And one of these resources, if I start to type, will be banner. Create a banner. So if I click here on this guy, it will give me a template of the banner resource. And it will fill in some fields that are related to the banner resource. So I need to fill in the namespace that this banner will be created in, the name of the banner. And then here I have a choice to create a login banner, the message of the day, and either use the node selector or specify the node names that I want this banner to be created at. Now I will call my banner simple banner. The namespace is EDA. You remember, this is the namespace that we use. This is the user namespace that our resources are configured in. You can have many namespaces. For this particular demo, one is just enough. Now, in the spec, what is a login banner? What is the message of the day? I don't know any of that. Like, if I want to know what can I configure for this resource, I can either hover over the fields and see what it is, like, yeah, login banner displayed before a user has logged in, message of the day is displayed after. What is node selector? A label selector to select nodes. So there's a lot of information that you can kind of get out of the system by just hovering over the nodes, but there is a better way. If you click on this icon here, which says resource browser, look at this. It will open It's kind of the OpenAPI browser in the VS Code, where you can see the types of the fields for the resources that you have been editing. So I've been editing banners, so that is why my resource browser shows me the banner. And here I can open this up and I can see what exactly I can configure. The same information that you can get by hovering over the nodes, but just more tailored. It's something that comes from the OpenAPI spec, and it's kind of the documentation that's there for you, free to use, and it's super easy to understand, okay, what can I fill in? I will have a login banner. So this is my login banner for the demo. And here, instead of selecting the node selector, I will pinpoint the nodes themselves. So the nodes is the list of nodes on which to configure the banners. And as you remember, we have 3 nodes, leaf 2, leaf 1, spine 1. So let's say I want to configure this on leaf 1 and leaf 2. So now I'm editing a resource. And how do I actually apply it? So currently I'm just editing text in memory in a file. I want to submit this. How do I do that? So there are several ways how you can do that. You can either directly commit this resource and this will be reflected, or you can use a transaction. Well, we'll talk about transactions because this is like a golden nugget of EDA. For now, I will show you a very simple way of creating a resource is just by saving this. I clicked Command Save or Control Save, or you can click on this check mark here, and it will ask you what you want to do. You want to apply changes, you want to add it to basket. This is the transaction basket. We'll look at this later. And yeah, and you can click apply changes. It will say, hey, do you want really to apply? This is the div that's gonna happen to the resource. And now it says successfully applied banner, simple banner. That was the name. Now, what you now get from this is here, see that we have site info category appearing in the resources tab. We did not hit refresh. We did not wait. It was immediately detected based on the WebSockets that VS Code extension uses. And if I click on this site info, there's going to be a banners kind that matches the kind of the resource. And if I open this up, there's going to be this simple banner. This is the guy that we just created. And if I click on this one, you see, this is what we configured. We configured 2 nodes, leaf 1, leaf 2. This is my login banner string. But we also now have the status, because this is now the resource that we fetched from the EDA API server. And it's not only having the specification of the resource, that's what we filled in here. We can actually close this now, it's irrelevant. But it also now has the status. And the status for the banner lists the nodes that we successfully configured the banner on. How do we check that we are not lying? I logged out of my leaf. I go back. Remember, we configured it on leaf 1 and leaf 2. Let's go to leaf 2 now. Look at this. This is my login banner for the demo. This stuff just works. So I'm not gonna connect to this one. We close this off. And that was a simple exercise of how you can create a resource, how you can identify which fields you can fill in a resource, and how you can simply commit a resource to the cluster. So now my resource is here, right? Let's actually create a bunch of resources together, and then we will see the power of transactions, that we will see that when you buckle up together several resources, you will be able to transact them simultaneously in a single ACID way. So for this, I have actually prepared a bunch of resources, right? I have something that I call a bad interface. This is the interface resource that I want to create. And the reason that it's called bad is because this interface uses an interface name that does not exist. It uses Ethernet 01, and 0 cannot be part of the interface name. So this resource we should not be able to apply. This resource should yield an error. And at the same time, we also will use a valid resource. We will use this test user. The test user is a user that can be configured on the node. I want to create a new user on my SO Linux switches with the username test and a password test123. But I want to create a transaction from these two resources. And as you can see here, I don't want to actually use this plus sign and create these two resources. I want to keep them in my declarative way in a YAML file. So here I have two YAML files, bad interface and test user. What can I do? I don't want to copy paste them into the edit window because that would be lousy. What we added to the VS Code extension is the ability to add resources from the file system, from the tree view to the transaction basket. You go here, right click, EDA, add YAML to basket. Node user test has been added. Let's add the bad interface. Bad interface, add YAML to basket. Now go back to the EDA extension and look at this. The transaction basket now contains two resources. The transaction basket is a way for you to populate resources and kind of stage a transaction. You have not applied anything. There is nothing in there that kind of immediately applied to the cluster. This is your basket, right? It's as simple as putting groceries in your basket. You haven't bought them yet, but they're there, ready to be bought. So here we have these two resources in the basket. From here, we can have two different workflows. We can either transact these resources, or we can dry run this. And the dry run is an amazing feature of EDA. It allows you to simulate what would happen if you would run your transaction, right? It would do a lot of magic in the background to validate the changes. And there are several validation techniques that would happen. But at the same time, it will not actually go to the nodes and execute any of the diffs. Like, your nodes will not be touched. It will be figured out in the cluster, in the EDA cluster, without actually bothering your nodes. As you remember, I said that my nodes, my resources, bad interface is actually a bad resource. It should not be applied. But now it's part of the transaction. So my expectation is that if I dry run this, I should be able to see that this would yield an error. And that would be, for me as an operator, a clear indication that this transaction should have not been successfully applied. So let's try this. I'm clicking on this button which says dry run the basket. You see the transaction number 128 happened. It has been logged in and it's red. Well, green means good, red means bad. Let's see what happened. We click on the transaction. And in the transaction, it's kind of immediately clear that there is an error. And there is a validation error. Unable to load JS path, schema leaf, interface name, could not parse, blah, 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 with value Ethernet 01. You remember this Ethernet 01 that we put in this bad interface YAML definition, Ethernet 01, that's where it's coming from. And our transaction caught this. We were able to simulate the effect of applying this transaction. We catch the error from the node, but at the same time, we're not talking to the node. There is some magic that as an EDA user, you will be privileged to use. That is something that our NPP does, the node push-pull node, because it contains the full kind of management server of the SR Linux, and it can do this kind of magic dry runs without actually bothering the nodes. So this is what happened, right? This is the invalid value was detected, and then the transaction has not been applied, right? We only dried it run. We never really applied it. But even with dry run, we can see that there is no point in trying to submit this transaction because it's not valid. And here we see that we had two input resources, the node user and the interface. We see that it yielded a bunch of things, like we generated a bunch of sub-resources. I will not spend too much time explaining this because that is a different talk on its own. Dry runs are fantastic. Well, let's say if you don't believe me, let's say if you say, okay, can you please run it? Maybe then, you would still apply this and we will see that a user has been created, but the interface would not be created. A very popular scenario with non-sophisticated network management systems where, partial changes are leaking to the network, and something that's failed, of course, failed and not present on the nodes. So let's try and run this transaction. Even though we just dry run it and we saw that it's not gonna fly, let's prove it. I click on this play button. This is the transaction apply button. There is a new transaction 129, and it says transaction failed. It has completed, like transaction ran to complete, but the success is no, nada, did not run. This time it's not dry run. Dry run no means that we actually run the transaction. And here we see exactly the same error. So this time around we actually wanted to apply the transaction, but it failed. Now, our transaction failed. That also means that our resource for the interface and for the user will not be seen here, right? There is no, like if we go to the interfaces, you see that there is no Ethernet 01 interface, right? Of course, it was not applied. The transaction did not succeed. But at the same time, the user is not here either. So my users, they're here, node users, and we only have the admin user. We do not have this test user that I wanted to create that was part of this transaction. We don't have that. And we don't have that because the transaction failed. So it was not committed at all. Like everything that we had in the basket is either applied or not applied at all across all of the nodes that you target. And of course, that is what you as an operator want to. You want this ACID principles, atomicity. It's either applied all or not applied at all. All right, cool. Now I wanted to show you something related to transactions as well, but something more complex. But before we do that, let's actually look at another dashboard that we have. Another dashboard that we have is the nodes. Now, the nodes dashboard shows you all the nodes, but not in a graphical format, but in a table format. You see these two leaves, one spine with a bunch of information about them in a table format. And you see here, there's like two action buttons. One action button will display you the configuration, the running configuration on the node, and the other one would be SSH to the node, right? So I will be able to SSH to the node, and you will see like exactly same effect. I can connect to the nodes from this nodes panel. Same thing, right? Nothing crazy. But the cool part about this is that you can look at the configuration. Like if you click here on leaf 1, you will see the configuration as it stands on the nodes. So this on this kind of right panel is the CLI configuration of leaf 1. And on the left, you see this gray blocks here. This is the intents that own this part of the configuration. For example, the interface Ethernet 1.1 admin state enable is on the node because of the leaf 1 Ethernet 1.1 resource that we have created in the cluster. Okay, this is here. This is the leaf 1 Ethernet 1.1. Browsing this configuration, you will be able to see what resources you have applied that had effect on this particular node. So you can see that the lag interface resulted in two interfaces, and this resource actually owns this. This is super critical to understand with these event-driven intent systems, that everything is being owned by a resource. Like what you see in the configuration is not something that you typed in yourself. It's driven by the resource that yielded this configuration that had been enacted on the node eventually. You can hide the annotations, and then there's your like pure CLI configuration. You can copy paste, you can just change to no color if you don't want to. You can have less color for small kind of color indications, or you can go full-blown color scheme if you want to. So this is the node configuration that you can detect or you can read from the VS Code extension directly. All right, now let's do one more thing here. We want to show you something more complex. We'll create a fabric in our triad topology. So right now our nodes, we just looked at the configuration, just had like interfaces configuration, users, basic stuff, but we did not create any fabric on it. We did not have any interfaces with IP addresses, nothing like this. For this one, I have this fabric YAML resource created. And this fabric resource is allowing us to kind of declaratively define the way we want the fabric to be deployed on our infrastructure. What you see here is a bunch of specification blobs here. So I will go quickly over the specification of this fabric resource. We want to select leaf nodes that have a tag role equals leaf. We want to select spines that have a tag role spine. For our interswitch links, we will have the link selector that will select links that have tag interswitch. We will use the IPv6 address pool, which is the way for EDA to request IP addresses from. For the system IPs, we will use a different pool. For the underlay protocol, we will use eBGP. And for the BGP ASN pool, we'll use the ASN pool. Overlay protocol, eBGP. So it's going to be IPv6 fabric with eBGP in the underlay and in the overlay. And these 24 lines of YAML will result in a bunch of configuration across our fabric. It will target all the nodes with these roles, with these tags applied to them. It will select the links. It will get the IP and addresses and ASN numbers from the pools, and it will create all of that in a declarative fashion with a transaction. Let's see how it's done. We do this EDA add YAML to basket once again. We go to our EDA extension. Now we see this in the basket, but we will first dry run this. We click dry run. Hey, now dry run succeeded. Fantastic. We open the transaction for the dry run. It says dry run yes. This is what we did. We submitted one input resource, my fabric, but we changed a bunch of things. We created BGP peers, we created default routers, we created policies, and this is magical, right? And this magic has a good and a bad side. The good side is that it happens automatically, like a bunch of things happening. The resources are created. The bad thing is that it's hard to gain users' trust when you see this. Like, I don't know what is going on. Like, what is this? I cannot understand. And that is where diffs come into the picture. The diffs that you can see here is a way for you to see what exactly is gonna be provisioned by the result of us submitting this fabric resource to the cluster. So let's click on the show diffs. The diffs by default will show you the node configuration differences. This means that it will show you what will change on the nodes in terms of the CLI configuration if we were to apply this transaction. And this what gains trust, because you as an operator, you will see, hey, now I see, well, if I apply this fabric, it will create this sub-interface with these IP addresses, IPv6, yes, because we chose IPv6 in the underlay. I will create a sub-interface system IP. This is coming from my system IP pool. Okay, so it checks out. I'm creating the default network instance. Yes, I have to have one to get some routing going. There's going to be some BGP configuration. There's going to be some road advertisements. Yeah, I'm creating a fabric. So you see how the 24 lines of YAML of this fabric created in this abstracted way actually results in a bunch of configuration elements on the nodes that an operator can easily understand, because that is what you would type in the CLI if you were to configure this manually. So this is what actually gains trust. You see exactly what is going to be applied with the rest of the configuration. So you can click show more and you will see the rest of the config. But then you see, okay, I'm confident with this change. This all checks out. This means that I understand what's going on. So there's like policies that will apply some policies to the BGP. And you can check different nodes. So on leaf 2, it's basically the same as on leaf 1, but on spine, it's different. On spine, there is like a separate configuration for your neighbors. You have 4 of them because we have 2 links for each leaf. Okay, so going back to transaction, we just dried it run. It has not been applied to the nodes. We just made sure that what we're about to apply is gonna fly. We get this confidence. We know that now if I click this green button, 99.999 is that this transaction is going to succeed. So let's do this. I click on the apply transaction. A new transaction is being recorded, 131. Fantastic. Now it must be on the nodes, right? It must be there. How do we check this out? We can go here to the nodes, for example, right? And we can open up a configuration view of this leaf 1. So view config. Hey, look at this. Before we saw this leaf 1 Ethernet and all the interfaces, but now we have this myFabric resource that contributing its piece of configuration to the resulting config. Now we see that the myFabric actually created this subinterface 0 with IPv6 underlay IP address. It's this resource that owns it. And here, if I open up my resource tab, you see that now I see the fabrics category. I can open this up and there's my fabric and it has a health. And if I open this up, I see a bunch of information about the fabric. This is what we submitted to the system. This was the specification of the fabric, but now we also get the state. We see the health is 100. All the interswitch links are up. The default routers are up. We have actually the leaf nodes that are making up this fabric. It's part of the state as well. We have the spine nodes. Everything checks out. And it's all in the configuration as well, right? I know it might be a lot, but this is what actually gets you this confidence and visibility in the system. It's properly declaratively managed. You have your resources that have been reconciled, not with eventual consistency, but with guarantees of transactionality and atomicity. Our transaction 131 has been run to completion. It has succeeded. All of these sub-resources, these default routers, interfaces, routing policies, they have been created in a uniform kind of one-shot transaction. If something would fail, the whole transaction will be discarded and none of the configuration would be on the nodes. But we also run the dry run and we knew that syntactically it was all good. This is great, but you can also run queries. Of course, why wouldn't you be able to run queries? The queries that you would typically run in in your UI, you can run it here. So I can say .namespace, .node, .srl, click run, and I get my nodes query results back. I have 3 nodes, all great. I can also run the natural query language, and I can also run the embedding-based query. I will not stop here, probably warrants another video on these guys as well, but you can run queries here as well from the VS Code. Let's see what happens if we mess up with our fabric. I want to show you that this health is actually a valid thing. So if I go to my nodes, I go to my leaf 1, and I will shut down one of the interfaces. So I go to the candidate, Ethernet, so it's not Ethernet 1.1. So I wanted to shut down one of the interswitch links, right? I don't remember which one was that, so I can open up my topology. I'm on leaf 1. Okay, Ethernet 1.1 connects me to spine 1. Okay, great. So let me go here, Ethernet 1.1. I wanted to see what happens to the health of this guy. Oh my God, look at this. The health is immediately dropping down. And that is because we shut down the interface. This interface is down. It affected the health of my fabric. My fabric was meant to have all of the interswitch links with a label interswitch up and running, but now it's not. Now I shut one of them down and my fabric health dropped, and it's not green, it's yellow anymore, and that the health is 75. If I open this up, it will actually say me that the health score reason metric ISL health score 75, and that is because we kind of calculated the the score based on different components that comprise the fabric. And here you will see that the impacting to this score is this ISL leaf1 spine 1, the leaf that the link that we just shut down, and it contributed to the health score. Not only this, of course it also yielded a deviation, but we also got this guy. We have alarms. Now our alarms, you will see here that there's a major alarm, ISL down, there's this default interface down. One shutdown of an interface created a bunch of, turbulence in our cluster, and the alarms have been streamed to us. Like if we open this alarm, it will say, hey, this is the ISL interswitch link, down alarm, the severity is major, probable cause is raised. If the ISL is in operational down state, well, for sure it is, because we just shut down the interface. But you can see that this web view for the alarms gives you a really good indication that something is not right? This is something that affected the state of the fabric. And there's gonna be a lot of alarms. You see, now we have 69 alarms. And this is all because now more alarms have been created because we just shut down an interface, and these caused a lot of alarms to be generated by the EDA. So what happens if I discard this deviation? Like, I admit I did it wrong, it should not be down, so I clear it up. Look at this and the fabric. So the alarms should be cleared and the fabric would go back to health 100. So I'm rejecting my deviation. Alarms are back to 59, and this score is coming up because, of course, it's not 100% immediately, because the BGP state has to be reconverged. We need to kind of establish the BGP peering back and get all the routes so that the health score can be, populated all the way back to 100. So it will take some time to actually things get reconverged. But once they are, you will see that the state would go back to 100. Yeah, now it's all here. Whew, yeah, that was a lot. I'm looking at my timer, it's 1 hour already. But okay, so maybe one last thing. What would it take us to switch this fabric from IPv6 based underlay to unnumbered? Good idea. So I open up my fabric here. So this is my resource. It now uses the interswitch links with pool IPv6. That means that we will use the IPv6 addresses from this pool to assign it to IPv6 links. I don't want that. I want my fabric to be unnumbered all the way. So how do I do that? I can edit this resource, and I can look it up here in my resource browser. What can I do? So under the interswitch links, there is this unnumbered string. Enables unnumbered interfaces on the ISL. For IPv6, only link local addresses are used unless a pool IPv6 is also specified. So that is what we need. We want link local addresses. So what we will do here is this. We are we're removing the pool IPv6, and we say unnumbered. And as I started to type, it auto-suggests me the field, right? Because it knows that from the schema. And in the unnumbered, we say IPv6, so that it's gonna be using link local IPv6. And it also filled it in because that is the value that is the default value, allowed values for unnumbered. How cool is that? So unnumbered IPv6, we click save. I do command save, but you can do like this one. And we will actually add this to the basket because I want you to see how a single line change in the fabric resource yields a bunch of stuff in the actual nodes. So I'm adding this to the basket. My basket now has this, my fabric changed resource. I will dry this run. I will dry run this. Transaction 134 has been created for this guy. I click this transaction, it succeeded, gives me confidence that my change was good, but I actually wanted to see what would happen, right? I go to the diffs and look at this. Instead of using the IPv6 global unicast addresses as we used before, it is now a route advertisement that we will create to actually do the IPv6 link local addressing working nicely. So on leaf 2, we have this route advertisement under IPv6 stanza. We will have it under the different interfaces of our leaves. And here we will have the dynamic neighbors created under the protocols BGP. That is how would the link local BGP work in our case, right? We will use the allowed peer access because we use it from the ASM pools that we defined in our transaction, in our resource. And that's it. And we remove all of the static neighbors that were configured before. Look at this, beautiful. Like less state to keep on the routers. We just enabled the dynamic neighbors and we created the route advertisement. So now if I feel confident, I can just click play, right? My transaction has been 135 succeeded. The health of the fabric is climbing up because we reconversion. We changed a bunch of state, but hey, here it is. The fabric is up and running again, health 100. I think that kind of shows you what the extension is capable of. It's your user interface for EDA in the setting of VS Code. I never opened any of the UI here, and I was managed to do a lot of workflows. I was managed to browse the resources. I was looking at the topology in the graphical format. I looked at my configurations on the nodes, and I saw this git blame view to understand what resources contributed back to that. I saw the resource tree that contribute to the state of the whole infrastructure that I manage. I was able to create a resource to run a transaction, to see the diffs, to do the dry runs. Maybe the last one would be to actually revert the transaction. That's how we started here. We wanted to revert things. So now I have this fabric created. I have a bunch of things in my nodes, like these dynamic numbers. What if I say, you know what? I want to not have any fabric at all. I want to go back in time where I had no fabric in my cluster. And that was, remember, so this was when we created the fabric. That was transaction 130. And in transaction 129, we were playing with the faulty BGP interface name. But this transaction, that's where we created the banner. What if I want to go back in time to this state? Easy. You see these two guys here? This is the revert button, restore transaction. Sorry, this is the restore transaction. This is the revert. Revert discards a single transaction, so it kind of negates the actions that you took in this transaction. It's like a single transaction scoped action. But the restore is a git restore. It goes back in time to the state of the cluster as was recorded by this transaction. And this is exactly what I want. I don't want any fabric. I want just like this simple banner created. I click this guy and I click yes. And it will restore, and this will result in another transaction. Everything you need is a transaction to guarantee that you can go back in time to any change that you've made. So now I reverted this back. And if I open this transaction and I look at the diffs, look at this. All of this is gone. The sub interfaces are gone. The dynamic BGP neighbors are not anymore. The routing policies, like there is no fabric at all. There is no fabric. And if we look at the transaction deleted resources, you will see that fabric was removed. And this was the input to my transaction with a delete action. And then we get rid of all of these sub resources that fabric was spawning. Okay, so that is I wanted it to be a quick introduction to VS Code EDA, but it was quite a deep one. But I think this demonstrates how streaming-based VS Code extensions are a reality, and it has a lot of interesting capabilities, and a lot of workflows can be unlocked if your VS Code extension uses WebSockets or server stream events to get this real-time feeling to your operations. And of course, it's not only the feeling, it's actually the operation patterns that are changing. Now you are getting used to get this immediate feedback. You see what's going up in your cluster. You see the health state reflecting life as you change things up. That is a massive improvement to these traditional poll-based things. So yeah, maybe next time you will give this extension a go. You will see how it works. It's all open source, by the way, thanks to Florian open sourcing the extension. You can see how it works and yeah, build something like this of your own. Thanks for watching. See you next time.